All right, so we're gonna just go through and label each of these with like what your approach would be. And we don't need to do this in any particular order. Like, for example, I would look for maybe the ones that I need to do that synthetic division for. Do you see one that looks like maybe you would do, like what jumps out at you? I don't know. What do you
14.
see? So yeah, that's what kind of what I'm looking for. Do you see number 14? What number would go in the little box off to the side? Yeah, so I'm gonna just, -2 was the right answer. Yeah, so I'm just gonna label that division. Like, and this is what I would do when I take this test too, is go through and kind of just label each of them, and then you can go back and do them in whatever order you want. Do you see another one that's like, to be honest, I really don't remember, so we're kind of in this together. I don't think I see another one like that. Do you see any that might be those like arc trig patterns? Number 7 is not. Why not? What? No, let's talk about it. There's a variable on the top. That's just going to be basic U substitution where you let the U equal the stuff inside. No, that was good. Let's try again. Do you see one that might be one of those arc trig patterns? So let's see. You would need to complete the square first, and then yes, that would be one of your arc trig patterns. I'm just going to write complete square. But completing the square is going to turn into arc something or other. Complete the square. 15 would also be complete the square. Good. And then it would be arc something or other. I'm trying to see if I see another one that would be one of those patterns. I don't think I do. So let's just go back. What would you let U equal for this first one? Yep, just x plus 4. For number 2, you would let U equal this, yeah, the stuff that's inside of there. Sorry, is this past the glare? Is that better? Okay. For 3, you would let U equal x cubed minus 7. Good. For 4, you would let U equal, do you see how it's f of this stuff? Just instead of square root of that stuff or cube root of that stuff, it's just f of that stuff. Just instead of an actual function, they just wrote f, but it's just going to be the insides. What would you let U equal for number 5? I like to just do square root of x because I like to just kick the coefficients out. That kind of boils down to personal preference, what you do with the numbers, but at least square root of x has to be in there. All right, how about 6? X cubed, good job. I was gonna say there's a lot in that one. How about 8? 5x plus 2. 9, it would be, yep, the denominator, good job. For 10, it would be the 4x squared minus 5. For 11, it would be the 5x. That's almost identical to the one that was on your quiz. 12, it would be x to the 4th. And this I threw on there, well, because it was on AP Classroom. This is not U substitution. You actually would just take each part of that and divide it by x, and you don't even need a U substitution. So actually, let me grab a piece of paper, and 13 will be the first one we do together. I'm not going to do them all. I'll do a few, but we'll do 13, and then I'll let you guys pick a couple of other ones. And we'll do maybe like 4 or 5 of these ones on the front. But let's start with 13. So it would be integral from 1 to e, and you would just divide both parts of that by x. So what would the first term end up being? Yeah, like literally just x, right? X squared over x is going to just be x. Plus 4 over x. What I want you to do, though, in your imagination is pretend it is a 1 over x. Because what's your antiderivative of 1 over x? ln. It's just going to be 4 ln. Okay, like the 4 is just there. So you don't need a U substitution. You can just go ahead and do the antiderivative. What's your antiderivative of just x? X squared. Good. Plus, and then I said this one, it's 4 ln x. We're not going to put a plus c. It's such that 1 to e. We're gonna do upper minus lower, and you're gonna have to fight all the way to the bitter end because this is gonna be free, or sorry, not free response. This is gonna be multiple choice. So if you plug in E, that's just gonna be 1/2 E squared plus, and then you get 4 ln E. Actually, before I say anything, what do you guys think? If you plug E in there, they cancel out and it's actually just 4. It is, nice. This one's gonna be convenient too because it's 1. If you plug in 1, you're gonna just get 1/2. And then ln of 1 is 0. So like you don't even really need to write the 0. And so your final answer is going to be 1/2 E squared. What would that be? Plus 3.5, but we don't do 3.5. It would be 7/2. So I'm going to let you guys pick a few others. I would say let's do at least one of those complete the square ones and then pick, and I would say let's probably also do 4, but are there any others like, or what do you want to do next? I'll let you guys talk. Want to do 16? I'm not going to rewrite the problem because we have it here. I'm going to just go ahead and start doing the problem. First thing I would do is evict that 4. I'm going to kick that out. That's personal preference, but I think that does make things a little bit easier. So it's going to be 1 over great big square root. It's very jumbled up. Do you see how the x squared is not coming first? You're going to kind of like imagine that it is though. We're going to factor out a negative, but just from those two, and I usually say the first two, but you kind of need to pretend that 7. Actually, you know what? Let's do this. Scribble out the 7 and put the plus 7 at the end. There, now it's the first two. We're in charge. We can do that. So if you take out the negative, it would be x squared plus 6x. And this is where you complete the square. So what are we going to add on to that? 9. Good. Now here is the thing. I'm going to have to extend these lines a little bit. Not actually a 9, it is a negative 9. You see that? You have to turn a negative 9 back into a positive 7. If it helps you to make a number, like you don't have to do this. I'm just trying to, like, I'm a very visual person. I like to see it. What do you add on to turn a negative 9 back into a positive 7 like it's in the problem? Yeah. And it's going to be a perfect square, okay? All right, so we've got 4 integral 1 over gigantic square root. Actually, I'm going to take that 16 and put it back now. It's going to be 16 minus blank squared. What goes in the blank will be x plus something or x minus something. So like x plus 2 or x minus 5, you know, whatever it is. What is this one going to be? X plus 3, good. So we got through completing the square. After that, it's one of your arc trig ones. Is it arc sine, tangent, or secant? Which one? I heard a few different answers. Tangent is the one that doesn't have a square root. Oh, no. Okay. Let's review. No, that's fine. We're reviewing. A weekend happened. Tangent is the one that doesn't have a square root. This one's going to be sine. Secant would have like an extra little doodad in front. There we good now? Okay, cool. So off to the side, A is going to be a number. U is going to be a variable. So what is A for this one? 4, good. 4 squared is 16. U is x plus 3. And that derivative is just 1. So du is just dx. But the point is, we know it's arc sine. Does arc sine have the little fraction out front? No. The other two have a 1 over a, but arc sine doesn't. So it's just going to be 4, because that 4 is just kind of there. 4 arc sine. And then do you remember? I'll tell you if not. I'm just trying to. U over a plus c. So it'll be x plus 3 over 4 plus c. Good job. We got through it. Can I suggest we do the division one next? Oh, go ahead. Why do you always do that to me? That makes me feel bad. Go ahead. You can ask me a question.
I was asking.
It's u over a plus c. Mm-hmm. Yep. All right, let's do the division one, which was number 14. Oh, and that one has boundaries for extra fun. All right, so -2 is going to go in the little box. Your countdown is 1, -3, -7. So can I just have everybody do the division and we'll regroup and make sure we all got the same thing? So I don't want to like put you all to sleep saying all these numbers. Do you get a remainder of 3? Cool. Okay. So put your integral symbol. It's going to be 1x, or just x, minus 5. And then do you remember how to write the remainder? Yep, good. 3 over x plus 2. And this one had dx, and then this one had boundaries. You don't need to change them for that because we didn't do a u substitution. We didn't change the x's to u's, so you don't have to change this. You do have to do an antiderivative, though. The common mistake is people totally skip that step because it feels like you already did a whole lot of work, so I get it, you know. Antiderivative of x, 1/2 x squared, minus 5x, and then this would be 3 ln, good, perfect, x plus 2. And now we're going to have to battle through this because it's going to be multiple choice. So your answer choices are not going to look like upper minus lower. You're going to have to actually sort through it. So if you plug in 4 squared is 16, half of that is 8, minus 4 times 5, 20, plus 3 ln of 6. You can drop the absolute value because the absolute value of 6 is 6. And then if you plug in 1, you're going to get, oh, geez, it's a fraction. All right. A half, I shouldn't complain. Of all the fractions, a half is the easiest one to deal with. Minus 5 plus 3 ln of 3. I'm not sure how far they went with this, so I'm going to check my notes to make sure we go far enough with this. All right, 8 minus 20 would be negative 12 plus 3 ln 6. And then how you get through this is kind of up to you. This is just, you know, adding and subtracting numbers at this point. I'll tell you what I always do, though, is distribute the negative. Just negatives are the most commonly missed thing ever. And so I just distribute the negative so that I know I've got that taken care of. And then I'll kind of group everything together. So negative 12 plus 5 would be negative 7. Minus a half would be negative 7 and a half. What is that? Negative 15 halves. And then you've got plus 3 ln 6 minus 3 ln 3. Let me see how far they went with that. Oh, you know what? I have a mistake on my answer key. I missed a negative sign. Because I didn't have that as subtracted. Well, here's what I would do. I don't know how far it goes. I would factor the 3 out of those. And then for subtracting, that means you divide. Adding means you multiply, subtracting means you divide. It's your exponent rules. So you would just do 6 divided by 3, which would give you 2, is what's going on with that. Correct. And I actually, you know what? My answer is right, weirdly. I must have fixed my error in my head because I missed a negative on this line, but my answer is right. Because I was like, dang, I'm gonna have to repost this, but my answer is correct. So plus I'm recording this. All right, let's do, what was that other weird one? Let's do 4 and then I'll let you guys pick one more. And we'll have done all the like really hard ones. All right, so for number 4, we had u equals x squared plus 1. So go through your process. What is du going to be? 2x dx. And then let me pull this back out so that we can look at it. I'm going to have to fold my paper over so I can have all this up here at the same time. Sorry. Technical difficulties. All right, so let's see. I don't have a 2 in the problem, so we're going to have to adjust that with a 1/2. Yeah, go ahead. Oh, okay. So in place of the x and the dx, we're gonna put 1/2 du. So put 1/2 out front, du at the end. This is gonna look really weird, but what's still there? Yeah. Because the function is f and it's u substitution. Don't think too hard about it. Now we're gonna adjust the boundaries. It's not hard, but you just have to take these and plug them in right here. So if you plug in 1 to this, you're gonna get 2. And if you plug in 2 to this, you're gonna get 5. And now I'm kind of like out of steam because I can't do an antiderivative of something that I don't know what the function is. That's why we're gonna come back over here. And conveniently, do you see how this is integral 2 to 5? F of u du equals 9. So all of this that I'm putting the box around, that's all 9. And so it's just 1/2 of 9. And then why don't you guys pick one more of the like basic u substitution ones, because the rest of them were all kind of like that. Yeah, 5. That's the one with the square root. That's a good choice. 5 is a smart choice. All right, so we let u equal square root of x. I'm just going to write it again. What is your derivative of square root? I want you to just know this one. Close? 1/2 square root. And that's why when you guys were saying about that 2 there, I mean, it's really a 1/2. You get that right? Because the 2's in the denominator. You could kick the 1/2 out, but I knew I wasn't going to worry about it because this is in the derivative. Right? So in place of 2 square root of x in the denominator and dx, this is the part that we get to circle. You don't even have to adjust it because the 2 is there. In place of that, you're going to put du. And then what's still there? Yeah, but we're going to write e to the u. And then we're going to adjust the boundaries. Conveniently, they're both perfect squares. If you plug in 9, it's 3. If you plug in 16, it is 4. So what's your antiderivative of e to the u? E to the u. And then we're going to do upper minus lower.
So you don't have to do upper minus lower.
So what happened with 4 was they gave us the answer to this piece of it. So like if you knew what function f was, which we don't, you would do an antiderivative, you would do upper minus lower, but they're saying that answer is 9. Like they provided the answer for us. So like it happened, but we didn't have to do it. They just said that answer is 9. You guys know this is not e to the first, right? That's algebraically not a thing. You would just leave it like that. Do you want to pick one more? Is there anything else that looks super scary to you? I think I tried to do all the like hardest ones, but I want you to feel okay about it. So would you like to pick one more? Or I posted all the answers, so they're all up there. Yeah, 6. We'll do that one and then we'll do our break. All right, so we've got u equals x cubed. And then what's the derivative of that? Yep, 3x squared dx. I'm going to adjust that with a 1/3. So when you go to look at the problem, we're going to replace the x squared and the dx. And in its place, we're going to put 1/3 du. There's just also a 1/2 in the problem. So I'm just going to kick that out as well. And again, how you deal with those is kind of up to you. Because if you wanted to like try and turn this, you could put a 3/2 or what would it be? A 1/6. What's going to end up being a 1/6 anyway? I don't know. It's up to you how you get through that. You're going to get the same answer in the end anyway. So what's still there? E to the u. So this is going to be 1/6 e to the u plus c. And then your last step is to put the x cubed back in. All right, so you guys have learned enough to do like an entire free response question. which is cool. I don't have to like cut out parts of it. So what are you given? It's always, what did they give me? What are they asking for? Kind of thing. They gave you velocity and the units are feet per second, something per something else. Position would be feet, velocity is feet per second. What would acceleration be?
The derivative of.
Feet per second squared, and it would be the derivative of velocity. Good. Okay. Does it say anything else important? Oh, there is an important word in there.
Differentiable.
If it's differentiable, it's also, that's going to be important. It's going to come up in one of these. Okay. This is like red flag. Do you know what I mean? This is like, oh, this problem has a red flag. It may or may not be differentiable. Yeah. Okay. All right. Approximate. Does that mean we're going to get the actual answer? No, because you may have noticed we don't have a function. We have these 4 points and that's it. This is all we have to work with. Approximate v prime of 3. Derivative means slope. It is literally just a slope. Now for 3, which 2 points would you use? And do not be too proud to write them. 2 comma negative 8, 5 comma negative 4. Do not be too proud to write that. If you mess up a slope, you are going to be sad. So then do your slope. It's going to be negative 4 plus 8, good, over 5 minus 2. For the love of my sanity, do not do anything to that. However, it does say, take 2, include units of measure. This is feet per second, and we approximated a derivative of that. So it is feet per second squared. That's it. Move on. Interpret the meaning of that in the context of the problem. You have 2 choices. Either the velocity is increasing or the velocity is decreasing. Now, I am going to think through whether this is positive or negative because we're going to have to figure that out. So what would this be? 4 over 3, which is good. So we're going to say velocity is increasing at time what? Reread part A. If you don't say at what time, they won't give it to you. At time 3, because v prime of 3 is positive. And it's the approximation, to be fair. It's not like we didn't actually find v prime of 3, but that's good enough. All right. Letter C, justify why, oh, this is going to be a theorem. Why there has to be a time, C, on the interval 2 to 5, so we're looking here, when the velocity is negative 5. Why would negative 5 need to be on there? In between, intermediate value theorem, good. So we're going to say, since, and you can abbreviate that, since v of t is differentiable, it is continuous. Just get that out of the way. If you don't say that, they won't give it to you. All right. And what was it? Negative 5? Negative 5 is between v of 2 and v of 5. Those are the things you mentioned. Continuity, because differentiable, continuous, and in between. Also, I need to mention on this because a while ago I was reading through like what they'll give a point to and what they won't. I was kind of going through that. If you just say v of t is differentiable and continuous, they won't give it to you. You have to say since it is differentiable, therefore it is continuous. It is a subtle but important difference. Do you get what I'm saying? Like, okay, because this is true, this is also true. Yes. I am going to put that at the end. Now we kind of repeat the prompt. So you say, because v of t is differentiable, it is continuous. 5 is between blah, blah, blah. Now you repeat the prompt. So I'm going to say there must be, you'll be okay. We're just repeating it. There must be a time C when velocity is what? Is how much? What was the number? It was negative 5, right? Is negative 5 feet per second by IVC. So you mentioned continuity between and then repeat the prompt. Velocity is feet per second. Acceleration is feet per second squared. Also, conveniently, they put it in the problem for this one. Right there. Now, if you didn't like that one, congratulations, you're a normal person. I hope you like D though, because D is a really easy one and I don't want anyone to miss this. What does it say to do for D? A right Riemann, circle your subintervals. How many subintervals are there? 3. Let's circle them. We got 0 to 2, 2 to 5, 5 to 12. I know, I love these. These are like, you're going to get all the points. How long is the first subinterval?
2.
2, the number on the right, -8. Plus, then the next one, 3, -4. Plus the next one, 7, -1. That's it. Don't do anything to that, please. All right. E. Okay, this is where we're going to have a U substitution. Do you see how there's like guts of it there? All right. We're going to let U equal that inside stuff. I would not write T over 3. I would write 1/3 T. I find that that just goes a whole lot better. Don't write T over 3, write 1/3 T. All right, and then, so go through your process now. What's du? The derivative of this. 1/3. Now, it's not dx, though. It's dt. Like, just go with it. Just, they changed the letter of the alphabet. Okay? And we're going to adjust that with a 3. So in place of dt, we're going to put 3 du. What's still inside of there is v prime of u. Good. So we're just jamming every letter of the alphabet into this thing. And then you have to adjust your boundaries, which is not hard, but you have to do it. You're going to take the 0 and the 9 and plug it in right here. So if you plug in 0, you're going to get 2. If you plug in 9, 1/3 of 9 is 3 plus 2 is 5. Now you do an antiderivative. They did this on purpose because they don't give you undoable problems. If this is v prime and we do an antiderivative, that takes you back to just v. You unprimed it. It's an antiderivative. And then you're going to do upper minus lower. We did an antiderivative. That's what this means. So we just got rid of the prime. It was a derivative, but we did an antiderivative. Kind of like if you have, this is really acceleration. If you go backwards, it takes you back to velocity. If we were to do it again, it would take us back to position. You're just going backwards. Oh, I'm so sorry because I messed up. Thank you. Blasphemy and sacrilege. Can't believe I did that. Thank you. All right, so we're going to do upper minus lower. So we're going to plug in 5. What is v of 5? That they have to have either given that to you or given you the ability to find it. We have to be able to find v of 5. Yeah, it's -4. Do you see that? Times 3, negative, or you can just write 3 times -4. That's fine as well. And then lower boundary, if you plug in 2, what's v of 2? -8 times 3, -24. But again, you could just write 3 times -8, and that's fine as well. I'm running out of space. How much more is there? See if I can make this work. I'm almost out of room. All right. There's another particle moving around now. Particle Q is modeled by a twice differentiable. They throw that in there a lot. Twice differentiable just means there aren't any issues. All right. It is known that h of 2 equals 1. They give you h prime of 2, and they give you h prime of 2. Is the speed of the particle increasing or decreasing? How do you tell speeding up or slowing down? If what has the same sign? You look at velocity and acceleration. If they have the same sign, what does that mean? Speeding up. If they're opposite signs, slowing down. So this piece of information is extra. You don't need that. So we are going to say speed is increasing. Oh, I meant to ask you that. Speed is doing what? Increasing. At what time? If you don't say what time, they will not give it to you. At time 2, because h prime of 2 and h prime of 2 are same sign. Yeah, I'm sorry, I know my handwriting is often. Do you have a question? Okay. All right, last one, G. This is gonna use a little bit of vocabulary that I haven't taught you yet. We're gonna just sort of ignore that part. It says differential equation. It just means this. We've talked about dy dx. That means derivative. Cool. All right. And we haven't talked really about initial condition, but it just means this point is on there, -2, 1. Do you see that? They even write it out as a point, -2, 1. It says write an equation. What two things do you need to write an equation? Point and a slope. We have the point. I'm going to have to write on here because I ran out of space. Find the slope. Slope comes from derivative, which they conveniently handed to you. You're just going to plug in -2 for x and 1 for y. So -2 squared, 4 times 3 is 12. If you plug in 1 for y, that would just be -7. So your slope is 5. I just took -2 and 1 and plugged them in. Are we all together there? -2 was x, 1 was y. So this is your slope. This is your point. Just put it all together. It'll be y minus 1 equals what? 5? X plus 2. And that's your answer. I like that one. That one was good. I liked that one. I liked F. I liked D a lot. That was a good one. And I liked A. A was just a slope. So about half of them were pretty easy.